Yes, sir. Today I'm going to explain about the how implementation of binary ASK. See, the implementation of binary ASK, okay, it is going, it is basically works on hook method, means on and off key method. Okay, how it is on and off? Okay, when it is on, if the bit is 1, it is going to be on. Okay, if it is the bit is 0 or the value will be 0, it should be a off method. Okay, see, this is the implementation of our binary ASK diagram. Okay, here now I am going to pass the digital value, okay, or it may be a digital data. Okay, it is going to multiply with, okay, multiply with our oscillator. Okay, the oscillator, it is going to release the frequencies with the help of bandwidth. Okay, it may be high frequency or it may be low frequency based on the usage. Okay, it is going to provide the result. Okay, then how it is the result will be comes like this. Okay, see, if it is 1, yes, means it is going to take the transaction. If it is 0, there is no transaction happen here, means it should be a nil, means it should be a null value or it may be a 0 value. If it is 1, yes, it is going to take the transaction, means these all are the modulated signal. Okay, because previously I am going to pass the digital data, that digital data I need finally expected result has the analog signal. See, this is the signal, okay, which we got by using the frequency, by using the frequency, or this method we call it as a carrier signal. Okay, this is what our binary amplitude shift key. The one is multi-level amplitude shift key. In that multi-level amplitude shift key, it is going to produce many number of, means 2 or more amplitude. Okay, it is going to released at a time. This method we call it as a multi-level amplitude shift key. Then, so this is the next type is the frequency shift key. The frequency shift key, like it's the here the big changes will be happens at the frequency level. Okay, how the frequency will happens here? Like initially in amplitude shift key we have taken only one bandwidth, but here we supposed to take two types of bandwidth. Okay, means we are going to split it in that bandwidth into two terms. Okay, how it is going to taken as, see here, you look at this, I have splitted the single bandwidth into two two partition. Okay, that one partition I'm going to call it as a f1 and another partition we call it as a f2. The given f1, the given one bandwidth, I'm going to marking as a midpoint here f1, and another another bandwidth midpoint I'm going to consider as a f2. Okay, this f1 plus f2 we call it as a 2 delta f1 plus f2. Okay, I'm going to repeat this f1 and f2, we call it as a 2 delta f1 and f2. The before that, the frequency shift key, okay, how it is going to happen? The frequency shift key of the carrier signal, it is varied. Okay, where it means it is going to vary to represent the data. The frequency of the modulated signal is constant during the one signal element, but changes for the next signal element if the data element changes. Both peak amplitude and phase remain constant. Okay, it is nothing but, see, it is going to changes happens at the frequency level. Okay, there is no changes, or there is a doesn't changes happen at the amplitude and the phase level. How? See, this is the data I have taken 10110. Okay, this is the sequence. Okay, I have taken binary sequence here. If it is 1, yes, it is going to take the transaction normally. If it is 0, means it should be a weak, little bit weak. Okay, there is no that type of fully energy of frequency, it won't going to produce. Okay, it should be produced the very like a weak frequency. Okay, so this is the changes, okay, which we had, like a comparison between our amplitude shift key and frequency shift key. Okay, in amplitude shift key, if it is 0 means not at all passing any value, it should be a null value. But if in frequency shift key, it is going to produce the frequency but not too much of energetic. Okay, it should be a like a very weak frequency, or it is a very less of energy that frequency it is going to produce. See, this is a major difference of our frequency shift key and amplitude shift key. Then one more here, the like here also frequency shift key. Okay, we are going to talk about two methods or two levels. The one is binary FSK and second one is a multi-level FSK. In binary level, like a binary FSK, a binary FSK we consider as a two carrier frequency. Okay, that two carrier frequency we call it as a F1 and F2. We supposed to use the first carrier's frequency of the F1. The data element is 0. We use the second, like a second data element is 1. However, we can note that is the unrealistic example, used only the demonstration of purpose. Normally the carrier frequencies are very high and difference between them is very small. Okay, it is nothing but, okay, our bandwidth f1 is and the middle of the other bandwidth is f2. For both f1 and f2 are delta f. Okay, we I am going to consider as a both f1 and f2, I am considering as a 2 delta f. Okay, before that, like see, this is the one bandwidth. Okay, this is the another bandwidth. Okay, so it may be a 2 delta f, okay, of the frequency. Now the bandwidth will be B is equal to 1 plus D into S plus 2 delta F. Okay, so here same B is equal to nothing but it should be a bandwidth, S is nothing but should be a signal rate, and 1 plus D is, okay, the D value will be the range from the value range from 0 to 1. Then 2 delta F is nothing but it contain two frequencies, so that I am going to refer as a f. That means 2 delta f is nothing but like it is going to taken as the frequency of f1 plus f2. Means I'm going to adding two frequencies here. This is the big changes happens in the frequency level. Then like in this like a frequency shift key, we are going to talk about two things, that is coherent and non-coherent. Okay, the coherent FSK schema, we are going to changes happen from the one frequency to another frequency. Okay, like which is does not affect to the current phase and the signal. But in coherent FSK, okay, coherent FSK, the switches from one signal to the another only occurs at the same phase in the signal. Okay, if the phase will be remain same, okay, this method we call it, the frequency will be vary. Okay, that should be happens in the coherent FSK. Non-coherent FSK, okay, the frequency and the phase it won't change. Okay, it won't change at presently. This is a difference between coherence and non-coherence. And this is the multi-level FSK here. The multi-level FSK, see, it is a combination, or it is a similar to the our amplitude FSK. Okay, it is going to use the multiple bit per signal element. Okay, means it is going to provide the multiple frequencies, the each one to represents a group of data bits. Now the bandwidth is equal to 1 plus D into S plus L minus 1 into delta 2F into L into S. This is the bandwidth of this our multi-level FSK. See, the same thing, if it is 1 it is going to provide the frequency, if it is 0 it is going to provide the very less or low frequency. Then see, with the help of this digital data, it is going to convert it, or it is going to with the help of our voltage control oscillator, it is going to provide our as a, like a actual result. Our voltage control oscillator, okay, it is going to it is going to provide whether the given data, or like our the given oscillator Okay, it is going to changes its frequency according to the input voltages. Our voltage control oscillator, it is going to changes the value according to the input voltage. Okay, then finally it is going to produce the our expected result. Then what is the shift key here? The shift key here, like whenever the shift key technique or the transaction will be happen during that time, the phase